Okay, now we're on to part 5 of our review, and we're starting with cubic functions. And cubic functions, as you see, are functions where our highest degree term is a third degree term. So we've got something to the third power. Cubic functions are different than your quadratic functions. Quadratic functions, typically you see your graph, you have the parabola. Cubic functions can actually move in any number of ways. Normally they have 2 or 3 directional changes. Sometimes they don't have any direction changes, but they do have behavior changes at what we call a point of inflection. And we'll get to that later. But right now what we're going to look at is factoring these cubic functions. So this is not necessarily a function yet. It's just a cubic expression, because this isn't set equal to f of x or any other value. It is not a function. So what we're going to do is we're going to factor this. And we've seen factoring like this before. Remember, when we have 4 terms, first thing we do is we look and we see, is there anything that we have in common? Remember that nice old GCF we look for, that greatest common factor. Not all 4 terms have an x, so I can't extract an x or divide an x out or factor out the x. And we have 16, 6, 56, and 21. So if I'm trying to look for something that goes into all 4 of these terms, it does not exist. There is not a variable or a constant that does fit into all 4 of these terms. So what I'm going to do is I'm going to factor by what we call grouping. When you have 4 terms, and you can't factor a GCF and you can't get it down to a trinomial, you can use grouping. And the way I always learn grouping is I always draw a line right down the middle of my terms. And I'm going to have basically 2 groups. So let's look at group number 1. All right, group number 1 is going to be this group right here. So I'm going to look between these 2 terms, what is common? What is the greatest common factor? Well, between 16 and 6, my greatest common factor is 2. I can factor out a 2 from both of these constants. Between x cubed and x squared, I can factor out an x squared. So what that's going to leave me with is, remember, we're doing reverse distribution. Instead of multiplying it in, we're dividing it out. 16 divided by 2 is 8. And x cubed divided by x squared leaves me with 1x. Now let's look at the second term. If I take a negative 6 and divide by positive 2, that leaves me with negative 3. And x squared divided by x squared is just 1. So that's it. I have 8x minus 3. So that's my first group. So let's look at my second group. If I look at my second group, I have negative 56x plus 21. If you look at my first group, I need a positive x term and a negative constant term. Well, my x term here is negative. In order to make it positive, that means I'm going to factor out a negative value. So between 56 and 21, we do have a greatest common factor. And that greatest common factor is 7. And I'm going to take out a negative 7, because that, dividing this by negative 7, negative 56 divided by negative 7 makes this positive 8. And I'm left with 8x. Now I'm going to divide the negative 7 out of the 21. So 21 divided by negative 7 gives me 8x minus 3. So I've completed the first step of the grouping process. So the next thing I'm going to do is I'm going to look at these, and I'm going to find again the greatest common factor. It's in a different format, but it's still the greatest common factor. And the greatest common factor between these 2 terms is 8x minus 3. Because isn't 8x minus 3 multiplied by 2x squared? And isn't 8x minus 3 multiplied by 7, or negative 7? So I'm going to factor out my GCF, which is 8x minus 3. And when I factor out the 8x minus 3, that leaves me with 2x squared. And when I factor out the 8x minus 3, that leaves me with minus 7. So my final answer is 8x minus 3 times 2x squared minus 7. And that is how we factor by grouping. So that's number 29 on your review. So let's move along and look at number 30. Number 30 is similar format. We've got 42x cubed plus 24x squared plus 49x plus 28. So once again, I want to look for a GCF. Is there a greatest common factor between all of these terms? Is there something I can extract, something I can divide out? Variable-wise, no, because 3 of these terms have x's, 1 of them does not. All right, so that's not something we can use. Let's look at the smallest factor, 24. 24 does not go into all 4 of these terms, so it can't be 24. So we need to look at the factors of 24. The factors of 24 are 24 and 1. That doesn't help us. 8 and 3, 6 and 4, 12 and 2. So let's look at 12. Does 12 go into all 4 of these? No, it does not. Does 8 go into all 4 of these? No, it does not. Does 6 go into all 4 of these? No, it does not. Does 4 go into all 4 of these? No. Does 3 go into all 4 of these? No, it does not. And 2 does not either. So that doesn't really help us. None of these go in there. I mean, the 1 obviously does, but that doesn't help us. So we're going to group these. And let's look at our first group. We don't have a GCF, so we're going to go straight to grouping. Between 42 and 24, there is a common factor here. And that common factor is 6. So I'm going to pull out a 6. And then x cubed and x squared, I can factor out an x squared. So what that leaves me with on the inside is 7. 42 divided by 6 is 7. And x cubed divided by x squared is x. 24 divided by 6 is 4. And x squared divided by x squared is just 1. So I'm done with that group. So let's move over to group number 2, which is this group right here. And again, I'd like to keep everything color-coded so you can see it. So I have group 1 and group 2. All right, so let's look at group 2. Between 49 and 28, I do have a greatest common factor, and that is 7. And I have positive, positive over here. Everything's positive, so I don't have to worry about signs, so I know it's going to be plus. 49 divided by 7 is 7, and that leaves me with an x. And 28 divided by 7 is 4. So now I'm ready to do my next set of GCFs, greatest common factors. The greatest common factor here is 7x plus 4, because it's multiplied by both 6x squared and 7. This is a full expression, just like this one was, and this is my greatest common factor. So I'm going to factor out 7x plus 4, and that's going to leave me with 6x squared plus 7. And that is my final answer to factoring this cubic expression. Remember, it's not a function if it's not equal to f of x. We're not performing an operation with an equation. So it's just an expression. All right, so let's move on to the last example of factoring cubics using grouping, and that will be number 31. And on number 31, we have 21x cubed minus 63x squared minus 35x plus 5. So what I'm going to do first is the same thing. I'm going to look for a GCF. The smallest factor is 5. 5 does not go into all of these, so there is no GCF to pull out. So I'm going to go straight into grouping. So I'm going to look at group number 1. I have 21 and 63. Actually, the greatest common factor between those two is 21. 21 actually goes into 63 3 times, so I can factor out a full 21. When I factor out the 21, I can also factor out an x squared. So 21 divided by 21 is 1. We don't have to write that because it's understood. And x cubed divided by x squared is just x, so I'm just left with x. 63 divided by 21, and it's a negative, is 3. And x squared divided by x squared is just 1, so it's just x minus 3. So let's go to our second group. Now again, I have positive x, negative constant. Over here I have negative x, positive constant. So when I factor out, I want to factor out a negative so that the signs change and give me something that matches the first one. So between 5 and 35, I can factor out a negative 5. When I factor out this negative 5, negative 35 divided by negative 5 gives me a positive 7. And I've got an x in there. Then I have negative 5 divided by negative 5 is minus 1. So I have 7x minus 1. Now if you look at these, there is no greatest common factor. There's no greatest common factor between the three of these. So the question is there anything I can do to get a greatest common factor? And when you look at it, there's really nothing that we can do. The other option is you can actually try rearranging and regrouping if you want to try to regroup. So let's just, let's regroup this for fun. And let's put negative 63, whoops, negative 63x squared together with the 35x. And let's put the 21x cubed together with the 5. Now, if you look at these, this is not going to create anything that will help us either. Because what can I not factor out here? I cannot factor out an x. So when I try to group these, I'm not going to be able to factor out. I'm going to be stuck with an x cubed, and I won't have an x cubed there. So this won't work. So let's try another combination. Let's try the, let's see, we've had x cubed and x squared together, and we've got x cubed. Let's try 21x cubed minus 35x minus 63x squared plus 5. But if you look at this again, that does look rather unbalanced. If I tried to do this, I've got a 63 and a 5 and a 21 and a 35. That is not going to match up. So there is no greatest common factor here for grouping. That means that I can leave it like this. That is as far as I can go in the factoring process. We are done here because there's nothing more I can do as far as factoring. I'm stuck. So the other thing I can offer is trying the different combinations, but again, we saw that that does not work. It's not going to work. So basically, we're done here. This is as far as you can go. And this is factoring cubic functions by grouping. Now we're going to look at sum and difference of squares, but we'll do that in the next video.